Hello, hello. We're going to look at some example problems of problems where we're going to use the Pythagorean Theorem to find missing lengths of triangles. So, number one, we have a triangle with it's a right triangle, right? So, in order to use the Pythagorean Theorem, it has to be a right triangle. One side is 9. One side is 12, right? These are the legs of the right triangle, and our hypotenuse, which is opposite the right angle, is x. It's unknown, right? These are the legs, right? Okay. Well, we know for a right triangle that Pythagorean theorem, a squared plus b squared equals c squared. Okay. And these are the legs, and c is the hypotenuse, right? So we'll fill this in with 9 squared plus 12 squared equals x squared. Okay, and then we'll just simplify and solve for x. So 9 squared is 81. 12 squared is 144. And we still don't know what x squared is. Then we'll add 81 and 144, so 145 plus 80 is going to be 225 equals x squared. So we take the square root of both sides to get x by itself. And so x equals the square root of 225, which is 15. And typically when we do square roots, we use plus or minus with the answer. So you might see plus or minus 15, but when we're talking about the length of a side of a triangle, that can't possibly be negative, so we leave it 15. This problem, if you'd have noticed that 9 was a multiple of 3 and 12 is a multiple of 4 with the same factor, if you divide each of those by 3, you get 3 and 4. That tells you that this is a 3, 4, 5 triangle, because 3, 4, 5 is what we call a Pythagorean triple. And so you'll notice that 15 is also 5 times 3. So that's one of those things. It's just a little shortcut that if you know that, you can sometimes, some of these problems are really, really easy. Okay, number 2, our problem this time, it's one of the legs that is unknown. Okay, so we're not going to have equals x squared like we did over here. We're going to have the x is going to be one of the legs. So we'll do 8 squared plus x squared equals 14 squared. Okay? So we'll simplify and solve. We get 64 plus x squared equals 14 squared, which is 196. So now we'll subtract x squared equals 196 minus 64. So 6 minus 4 is 2, 192. 90 minus 60 is 30, so we get 132. And x equals the square root of 132. Okay? This is not a perfect square like 225 was, so we have to do something different. We can approach this two ways. We can round to the nearest tenth, and you can almost do that in your head because 132 is almost directly between 121 and 144, which are 11 and 12 squared. So it's going to be somewhere between 11 and 12, and if you plug it in your calculator, you'll see that it actually rounds right to 11, not 0.4, 0.5. Okay, it's 11.48, which to the nearest tenth is 11.5. That's one way to do it. Okay, or we can simplify the radicals. 132 is 4 times 33. So we can break this up into the square root of 4 times the square root of 33. And the square root of 4 is, of course, 2. So we pull that perfect square out, and we get another acceptable answer. Any problem should specify how they want you to answer, and if not, then I guess you can just choose. Okay. Our last problem that we're going to look at gives us the lengths of the sides of a triangle and asks, is it acute, right, or obtuse? To test this, we're going to plug these values into the Pythagorean theorem, with the longest one being our hypotenuse. Beware when you read these problems. It's always the longest one. That's not necessarily the last side mentioned. Sometimes they'll stick that long one in the front or in the middle. So make sure you notice that you're using the longest side, not necessarily the last one. but in this case it happens to be like that. So we'll plug it in. We use 5 squared plus 8 squared, and then I'm not going to put equals. I'm going to put a little question mark, and 10 squared. Okay, 5 squared is 25, 8 squared is 64, 10 squared is 100. Okay. Let's see, 64 plus 5 is 69, plus 20 is 89, and this is still 100. 100 is bigger than 89. 89 is less than 100. So we know they can't be right, because for them to be a right triangle, those would have to be equal. So when I do these, I always focus on the hypotenuse. If it was a right triangle, then they would be equal. The hypotenuse is bigger, so it's kind of like it goes that way, right? So our triangle actually kind of looks like that, which gives us a bigger angle than 90. So the answer is obtuse. If the hypotenuse was smaller and it would kind of have to move in like that, then this angle would be smaller. So that's sort of the opposite situation. And of course, if they're equal, then it's right. Okay? Hope that helps, and we'll see you next time.